Welcome to another episode of AI Frontiers, your gateway to the fascinating world of machine learning. Today's focus is on the computer science learning category, abbreviated as cs.LG on the arXiv preprint server. Machine learning, a subset of artificial intelligence, has revolutionized various industries by enabling systems to improve performance over time without explicit programming. Unveiling machine learning frontiers, synthesizing 134 papers published on 2025-05-20 to 2025-05-20. In this episode, an overview of the presentation will be provided. The significance of machine learning in today's world will be explored. A deep dive into the dominant research themes from 2025 will be undertaken. Groundbreaking findings and methodologies will be reviewed. Influential papers and their impact will be highlighted. Future directions and ethical considerations will be discussed. Machine learning is a subfield of artificial intelligence that focuses on the development of algorithms and statistical models. These models enable computers to perform specific tasks without explicit instructions, relying on patterns and inference instead. This field is crucial as it powers many technologies used daily, such as recommendation systems on streaming platforms, fraud detection systems in banking, and autonomous vehicles. The research in machine learning often involves the use of neural networks, statistical models, and other computational techniques to analyze and interpret data. The key theme in machine learning research is the quest for scalable and efficient models. Researchers are exploring ways to train large models more efficiently, reduce computational costs, and improve the speed of inference. For example, the paper Polar Sparsity, High-Throughput Batched LLM Inferencing, with Scalable Contextual Sparsity, introduces a method to scale contextual sparsity in large language models. This ensures high throughput and low latency inference, crucial for applications requiring real-time processing, such as chatbots and virtual assistants. Enhancing the robustness and reliability of machine learning models is crucial, especially in high-stakes applications. Papers in this area focus on improving model generalization, handling distributional shifts, and ensuring fairness. For instance, the paper The Achilles Heel of AI, Fundamentals of Risk-Aware Training Data for High-Consequence Models, discusses strategies to curate high-quality training data. This improves model performance in rare, high-impact scenarios, particularly important in fields like healthcare and autonomous driving. As machine learning models become more complex, there is a growing need for interpretability and explainability. Researchers are developing methods to understand and explain the decisions made by these models. The paper, Anomaly Detection Based on Critical Paths for Deep Neural Networks, presents a novel approach to detect anomalies by identifying critical paths within neural networks. This enhances the interpretability of these models, essential for building trust in AI systems, especially in sensitive applications like finance and healthcare. Integrating multiple data modalities such as text, images, and audio is another important theme in machine learning research. Multimodal learning aims to leverage the complementary information from different data sources to improve model performance. For example, the paper Imitation Learning via Focused Satisficing explores how to imitate the best parts of demonstrations across different modalities. This is particularly useful in robotics and autonomous systems, where integrating multiple sensory inputs is crucial. Several groundbreaking results have emerged from the research in 2025. Efficient training of large language models in low-precision arithmetic achieves state-of-the-art accuracy, while significantly reducing computational costs. Improved anomaly detection in deep neural networks enhances model reliability. Enhanced robustness in high-consequence models is achieved through smart sizing training data strategies. Several common techniques are employed across the papers, each with its own strengths and limitations. Speculative decoding is used to improve the efficiency of large-scale autoregressive models by enabling multiple steps of token generation in a single forward pass. While it enhances throughput, it can be challenging to implement effectively. Hierarchical reinforcement learning involves breaking down complex tasks into simpler subtasks, each handled by a separate policy. While it achieves strong empirical results, it introduces additional complexity and can be difficult to scale to high-dimensional goal spaces. Contrastive decoding is another approach used to enhance the performance of fine-tuned language models by prioritizing tokens that align with learned representations. While effective, it can be computationally expensive, requiring optimized implementations to be practical. Now let's delve into one of the most influential papers from 2025, Flattening Hierarchies with Policy Bootstrapping by cs.LG et al. The primary objective of this paper is to address the challenges of scaling goal-conditioned reinforcement learning to longer horizons. Traditional hierarchical RL methods, while effective, introduce significant complexity and hinder scaling to high-dimensional goal spaces. The authors aim to develop a flat, non-hierarchical goal-conditioned policy that can match or surpass the performance of hierarchical approaches. The authors introduce an algorithm that trains a flat goal-conditioned policy by bootstrapping on sub-goal conditioned policies with advantage-weighted importance sampling. This approach eliminates the need for a generative model over the goal space, which is key for scaling to high-dimensional control in large state spaces. The method is evaluated across a comprehensive suite of state and pixel-based locomotion and manipulation benchmarks. The results demonstrate that the proposed method matches or surpasses state-of-the-art offline GCRL algorithms and scales to complex long-horizon tasks where prior approaches fail. This paper contributes to the field by providing a more scaling and efficient approach to goal-conditioned reinforcement learning. Another seminal paper is the Achilles Heel of AI, Fundamentals of Risk-Aware Training Data for High-Consequence Models by Dave Cook et al. The objective of this paper is to address the challenges of detecting rare high-impact events in high-consequence domains such as defense, intelligence, and disaster response. Traditional annotation strategies that prioritize label volume over informational value introduce redundancy and noise, limiting model generalization. The authors aim to develop a training data strategy that emphasizes label diversity, model guide selection, and marginal utility-based stopping. The authors introduce smart sizing, a training data strategy that implements adaptive label optimization. ALO combines pre-labeling triage, annotator disagreement analysis, and iterative feedback to prioritize labels that meaningfully improve model performance. The method is evaluated through experiments that show the impact of curated data on model performance, particularly in rare class recall and edge case generalization. The results demonstrate that models trained on 20 to 40% of curated data can match or exceed full data baselines, particularly in rare class recall and edge case generalization. The study also highlights the importance of latent labeling errors embedded in training and validation sets, underscoring the need for embedded audit tools and performance-aware governance. The third influential paper is Anomaly Detection, based on critical paths for deep neural networks, by Fangzhen, Zhao et al. The objective of this paper is to develop a more effective approach to anomaly detection in deep neural networks. Traditional methods often struggle to detect outliers and adversarial inputs, which do not usually induce the same activation pattern on critical paths as normal inputs. The authors aim to extract critical paths from DNNs and apply them for anomaly detection, enhancing the interpretability and reliability of these models. The authors propose a novel approach that extracts critical paths from DNNs using software engineering techniques. The method involves identifying critical detection paths via genetic evolution and mutation. Since different paths in a DNN often capture different features for the same target class, the author's ensemble detection results from multiple paths by integrating random subspace sampling and a voting mechanism. The approach is evaluated on the anomaly detection task. The experimental results suggest that the proposed method outperforms state-of-the-art methods and is suitable for the detection of a broad range of anomaly types with high accuracy. This paper contributes to the field by providing a more robust and interpretable approach to anomaly detection in deep neural networks. Looking ahead, the future of machine learning holds great promise. The integration of multiple data modalities, the development of more efficient training methods, and the emphasis on ethical considerations will drive the field forward. As researchers continue to push the boundaries of what is possible, machine learning will play an increasingly important role in shaping the technologies of the future. Several challenges remain in the field of machine learning: the complexity of training large models, the need for more interpretable and explainable models, and the ethical considerations surrounding the use of machine learning in sensitive applications are ongoing areas of research. Addressing these challenges will be crucial for the development of more effective and trustworthy machine learning systems. In conclusion, the field of machine learning has made significant strides, with researchers addressing critical challenges and developing innovative solutions. The progress in scalability and efficiency, robustness and reliability, interpretability and explainability, multimodal learning, and ethical and privacy considerations demonstrates the field's commitment to advancing the state of the art. As the boundaries of what is possible in machine learning continue to be pushed, the potential applications and benefits for society are immense. From improving healthcare outcomes in underserved regions to enhancing the accuracy of weather forecasting, the impact of this research is far-reaching and profound. This synthesis was created using AI tools including GPT, Mistral, using model mistral-large-latest, TTS synthesis, using Deepgram, and image generation, using OpenAI. While the synthesized content underwent review by a human expert, it is important to acknowledge that some oversights may still exist. All references are provided. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.